Hello, in this video, we are going to learn how to identify a type of transformation from the function notation. The function we are using here is the quadratic parent function, f of x equals x squared. And the graphic on the right hand side it is a parabola. Open up, have the vertex at the point 0, 0, and the axis of symmetry is the y-axis. So in this case, the parent function f of x equals x squared is uneven function. Okay, so this review of the characteristic that we learned from the previous lesson. Okay, so let's just look at the second notation here, f of x minus 1. Can you predict what happened to our parabola, to the graph, if we take the parent function and then we minus 1? Now let's go ahead and graph it. So you can see right here that the parabola of our parent function is shifted down 1. Okay, so let's write the note right here. Shift this down 1 unit. Okay. So now let's go ahead and play with the next one. The next notation, I'm going to take it. So the next notation is f of x minus 1. So now you can see that now in your input now is the binomial x minus 1. Can you predict what happened to our parent function, to the graph of our parent function, which is to the parabola, if we see this notation? Okay, so let's go ahead and graph now. Now the graph is the green color. You can see that the graph is shifted to the right by 1. Okay, so let's go ahead and write a note here. Shifted right 1. Okay. Okay, let's play with our next notation. Now we have f of x plus 1. Can you predict what happened to our parent graph if we take our parent function plus 1? Okay, let's hit the graph. Okay, here we are. So you can see right here that the new graph is exactly the same graph compared with our parent function graph. It just shifted up 1. Okay, so let's write the note right here. Shifted up 1. Okay, so far so good. Let's look at the next notation. Now I'm going to go ahead and, before we hit graph, can you predict what happened if we see this notation f of x plus 1? So x plus 1 now is your input. So what happened to the graph? Okay, now let's go ahead and hit the graph now. And you can see right here that when you see f of x plus 1, this notation, so it takes your parabola, your parent graph here, which is a parabola, and it shifts to the left. So let's write it note now, shift this left. Shift it left 1. Okay, let's go ahead and move on to the next one. Okay, so let's look at this this function notation here, 2 times your parent function, right? So 2 times f of x. What do you think the graph will be? Or what happened to every single point on the graph? Okay, so let's go ahead and hit the graph now. Okay, so you can see right here, I'm going ahead and plot it on the graph so that you can see it. So the graph of our 2 times the parent function, it is a vertical stretch. It means that you will, so if you see this notation, so you have 2 times f of x. So this would mean that you are going to multiply y value of each point by 2. Okay, so let me show you here. Let's say I'm start with my parent function. So my parent function is the one outside right here, right? Okay. So this one, if I have the point, this is from our parent, so we have the points -1, 1. Yeah, because our parent is f of x equal x squared, right? So f of -1 is -1 squared, so that will give us 1. So again, f of -1, it gives you the y value or the output of the function when the input is -1. Okay, so that's what you have it point. Now think about, let me use different color here. Now think about you taking this point on your parent function, but you multiply the y value by 2. So this is the y value here. So you go ahead and times 2. Okay, so that would the x value. So now you end up with what? -1, 2. So you have a new point right here, -1, 2. So you can see that the graph getting taller. So we will say this will be vertically stretched. And again, what it means right here that you so in this case you are going to multiply each one of the y value of each point by 2 so that the graph is getting taller. Okay, so let's just look at the next case now. So I'm go ahead and grab the next one. Okay, so the next one we will have a 0.5 times our parent function. So before we graph, can you predict what happened? Okay, let's graph them now. So you can see right here that the graph getting wider, right? So since the graph getting wider, so this will, this we will use the term, this will be vertically shrunk. Okay, so what it means that you are going to, in this case, you have 0.5 f of x. So that it means that you will multiply each y value of each point by 0.5. Okay, so let me show you now. So the parent function, again, we go ahead and from our parent function, I'm just look at the point -1, comma 1. This is from our parent function. Now, and then now you are going to just take the y value of the point -1, comma 1. The y value is 1. You take the y value only you times 0.5, but the x value stay the same. Okay, so that's why you end up with the point -1, comma 0.5, which is right here. Okay, so that will give you the point -1, comma half. So that's why the graph gets wider. Okay, so let's look at the next one. Let me go ahead and take this away. And let's graph f of 2x. Now, before we graph this function notation f of 2x, can you predict what happened first? What happened to our parent graph? Okay, so let's grab it now, so you can see that. Okay, so f of 2x, you can see the graph is the green parabola. And in this case, you can see that the graph gets narrower or taller. Okay, so what happened here is that, so let's make a quick note right here. So f of 2x, that would be the horizontal chunk. Or when you say horizontal compression, it's exactly the same meaning. So again, just look at one point and then you see why. Okay. So if we look at the point from our parent function, again the point is -1, comma 1. Now let's go and look at the green parabola. Okay. So the 2 in front of the x, now you have to think about because you want to compress it, so you don't multiply your x value of each point by 2, you multiply by reciprocal of that. So I'm going to multiply each x value by reciprocal of 2. So again, we have f of 2x. So we multiply each x value by the reciprocal of 2. Again, the reciprocal of 2, which is half. So if you so basically you would take x value u times half. Okay, so I'm sorry I put this so you confuse. So you will multiply the x value by half. So I'm looking at my x value right here. So let's draw. Okay, so this is our x value. It is -1. But now we are going to take that x value, you will go ahead and multiply by half. So that becomes -0.5. Okay, and the y value stay the same. So that's why you end up with the point, with the new point right here. See that? So that will be the point that we have. I'm going to go ahead and write it below here. So that will be the point where x is -half, but your y is still 1. Okay. Any questions so far? So let's go ahead and move on to the next notation. And go ahead and I think I'm going to go ahead and erase this so it's not going to be very complicated for you. Okay. So let's look at the next notation. So the next one will be f of 0.5x. Okay. So again, before we graph it, can you predict what happened to f of 0.5x? Now let's graph it. Okay, so f of 0.5x, if you can see right here that the graph getting wider, right? And in this case, because it will, you think about it getting wider horizontally, right? So I am going to write the note right here first. So in some, when you read the book, this is how we say it. We would say that would be the horizontal stratus. Okay. So again, the notation is f of 0.5x. So what it means is that you are going to multiply each x value uh, of each point by reciprocal of half. So basically, which is 2, right? So you think about 1/2 and then you flip it, so it become 2. So therefore, I'm looking at, so let me just pick points on our parent function. So the points on our parent function is, this is the point -1, comma 1. Okay. Now we'll go ahead and take this point and we'll take the x value only. So we take the x value, which is -1. We go ahead and times 2. Okay. So that will give us -2, comma 1. So that will be our new point right here. So that's what you can see that the graph horizontally stretches. Okay, we have 2 more notation. So let's move on to the next one. I'm going to go ahead and erase it first. Okay, so let's just look at the next notation, please, dear. So the next one, -f of x. Can you predict what happened? So let's go ahead and hit the graph. And for the negative f of x, it means when you multiply -1 to your given parent function or your given function, the graph will be reflection or reflected in the x across the x axis. So let's make a quick note over here. This will be reflected across the x-axis. Okay, let's look at the next one. So let before we grab the last one, f of -x, can you predict what happened to the graph? Okay. First of all, before we begin, we just go ahead and review the characteristic for this function. This is the parent function, f of x equal x squared. Okay. And I'm just go ahead and just talk about the symmetry. Okay. So y-axis is the symmetry. And since the y-axis is the symmetry of this parabola, so this parabola or this graph represents an even function. Why? Because if you look at the point on the left and then the point on the right, both points have the same y, okay, with the opposite x. So since it's even functions and since the y-axis is the symmetry of the graph, now let me go ahead and graph f of negative x. So when we graph the f of negative x, we don't see nothing because f of negative x is the same thing as our parent function here. And what it means is that f of negative x, it means that when you reflect the graph across the y axis. But in this case, the y-axis is our symmetry. So this is reflected across y-axis. Okay. Now, thank you so much for paying being with me for this part of the video. I have one important summary I need you to write to your notebook. So let's share the summary now with you. Okay, let me clear out it. Okay, so can you write it to your notebook, please? So these are our transformation rule for functions, which is we just listed. So the parent function or the given function f of x, it can be whatever function, but the rule must be exactly must apply uh, the same. It doesn't matter what function. It can be a piecewise function at the same time. So go ahead and pause this video and copy this transformation rule for your function. Thank you.